Let's tackle question 5, part A. In this question, we want to determine the value of k for which this piecewise defined function f of x is continuous for all values of x. F of x is equal to x to the 5 minus 1 over x minus 1 when x is not equal to 1, and f of x is equal to k when x is equal to 1. To help you understand the question, I decided to sketch the graph of f of x. The red curve is what the function looks like when x is not equal to 1. When x is equal to 1, there's a point discontinuity at 1, 5. And we basically want to find the value of k such that the point 1k fills the hole in the graph. Let's go to Desmos to see the interactive version of the graph. Note that when we have k equal to 4, which is the example you see here, the point doesn't fill the hole. The point is outside of the hole. And neither does it fill the hole if we put k equal 4.2, k equal 4.5, k equal 4.8, but the point is getting closer to the hole. So if we go a little bit over 5, 5.2, again it doesn't fill the hole, but if we set it equal to 5, we see that the hole seems to be filled. So intuitively, k equal 5 seems to be our answer. However, we can't give this reasoning as our answer, since they want us to use our understanding of continuity in terms of limits to find the value of k. So let's do that now. Recall that a function f of x is continuous at a point x equal a if and only if f of a is equal to the limit of f of x as x tends to a. Hence, for the function we are given to be continuous at the point x equal 1, we need f of 1, which is equal to k, to be equal to the limit of f of x as x tends to 1. Okay, so what's the limit of f of x as x tends to 1? Well, as x tends to 1, we'd be considering values of x as x approaches 1 from below or above, but never when it is equal to 1. Since the function is defined to be x to the 5 minus 1 on x minus 1 when it's not equal to 1, it follows that the limit of f of x as x tends to 1 is equal to the limit of x to the 5 minus 1 on x minus 1 as x tends to 1. The numerator can be factorized into x minus 1 times x to the 4 plus x cubed plus x squared plus x plus 1, and we see that there's a common factor of x minus 1 in both the numerator and denominator. Cancelling those, we get x to the 4 plus x cubed plus x squared plus x plus 1, and its limit as x tends to 1 is equal to 5. Therefore, the limit of f of x as x tends to 1 is equal to 5. Therefore, put k equal to 5, and it would follow that f of x would be continuous for all values of x. Notice that this conclusion agrees with the intuitive explanation that I gave at the beginning. Hey guys, Dwayne here. If you're a Caribbean student struggling with K Pure Maths and you need extra help, then go to this link to join my free study group. Also, don't forget to subscribe to this channel and click the notification icon to get notified when I upload new videos. Thanks for watching, and see you next time.